This video is about discrete distribution. Are you willing to play this game? In a free throw basketball game, you have 3 attempts. The random variable x represents the number of successful basketball shots out of these 3 attempts. The probability distribution for x is shown in the following table. The player has a chance to win money based on number of successful shots. The gain for the player in dollars is shown in the table below, where a negative gain indicates a loss for the player. The random variable x represents the number of successful basketball shots out of these 3 attempts. For this event, altogether, there are 4 outcomes. X equals 0 means you missed all 3 shots. You made only 1 shot. You made 2 shots. You made all 3 shots. This is a typical discrete distribution. A discrete distribution is a probability distribution that describes the likelihood, means probability, of countable outcomes, such as 1, 2, 3, yes, no, true, or false. In the event mentioned above, we have 4 outcomes, which is countable outcomes. A probability distribution is a statistical function that describes all the possible values and likelihoods that a random variable can take within a given range. For this example, the probability of missing all shots is 0.3. The probability of making only 1 shot is 0.4. The probability of making 2 shots is 0.2. The probability of making all 3 shots is 0.1. Since this event has countable outcomes, for each outcome, we have corresponding probabilities. So this event is a discrete distribution. We can use a graph to show this discrete distribution. When x equals 0, probability equals 0.3. When x equals 1, probability equals 0.4. When x equals 2, probability equals 0.2. When x equals 3, probability equals 0.1. This is the diagram for this discrete distribution. Let's talk about players gain dollars in this table. If you miss all 3 attempts, you got to pay $10. If you can get 1 successful shot out of 3 attempts, you play the game for free. If you can get 2 successful shots out of 3 attempts, you can earn $5. If you make all 3 basketball shots, you can earn $15. The expected value of discrete distribution is this formula. When you decide whether you will play this game or not, you have to check whether the game is fair. 1. Expected value equals 0. We say the game is fair. This 0 means, on average, you don't earn any money from the game or you don't lose any money from the game. This X could be money, could be any other reward, or score, or point, and so on. We need to check whether this game is fair first. E of X equals, money is negative 10, probability is 0.3, negative 10 times 0.3 plus 0 times 0.4 plus 5 times 0.2 plus 15 times 0.1 equals negative 3 plus 1 plus 1.5 equals negative 0.5, which means on average, the player will lose 50 cents for each game. Since this game is not fair, we recommend the player not play this game. For discrete distribution, first of all, summation of all probabilities equals 1. Second, for a fair game, expected value equals 0. For a game, this X normally means money, any reward, score, or point. Let's go to guided practice 1. In a game, balls are thrown to hit a target. The random variable X is the number of times the target is hit in 5 attempts. The probability distribution for X is shown in the following table. Find the value of K. Since this is a discrete distribution, summation of probability equals 1, which means 0.15 plus 0.2 plus K plus 0.16 plus 2K plus 0.25 equals 1. Simplify. 0.76 plus 3K equals 1. By solver, K equals 0.08. So this K equals 0.08. 2K is 0.16. The player has a chance to win money based on how many times they hit the target. The gain for the player in dollars is shown in the following table, where negative gain means that the player loses money. Determine whether this game is fair. Justify your answer. The game is fair means expected value equals 0. Expected value equals summation of X times the corresponding probability. First of all, we need to write down the corresponding probabilities. Then we will use this formula. Remember this X is the player's gain, dollars. So negative 4 times 0.15 plus negative 3 times 0.2 plus -1 times 0.08 plus 0 times 0.16 plus 1 times 0.16 plus 4 times 0.25 equals negative 0.12. Since this expected value not equal to 0, therefore the game is not fair.